Good morning, children. So, today we will talk about the DNA as a genetic material and properties of DNA, genetic material. So, DNA versus RNA.
Children, till now, we saw that the series of experiments were conducted by Griffith, Avery Collin, and McCarthy to find the genetic material. The Hershey-Chase experiment was another milestone in search of genetic material. Alfred Hershey and Martha Chase in 1952 worked with the virus that infect bacteria called bacteriophages and proved that DNA is the genetic material. This experiment has three steps, that is infection, blending and centrifugation. In this slide you can see the first step, that is infection. They grew some viruses on a medium that contained radioactive phosphorus and some viruses on sulfur containing radioactive medium. Viruses grown in the presence of radioactive phosphorus contained radioactive DNA but not radioactive protein because DNA contains phosphorus but proteins doesn't. In the same way, viruses grown in the radioactive sulfur contained radioactive protein but not the radioactive DNA because DNA does not contain sulfur. Radioactive phases were allowed to attach to Escherichia coli bacteria. Then, as the infection proceeded, the viral coats were removed from the bacteria by agitating them in a blender, that is the second part, blending. The virus particles were separated from the bacteria by spinning them in a centrifuge. Bacteria which was infected with viruses that had radioactive DNA were radioactive, indicating that DNA was the material that passed from the virus to the bacteria. Bacteria that were infected with viruses that had radioactive proteins were not radioactive. This indicates that protein did not enter the bacteria from the viruses. DNA is therefore the genetic material that is passed from virus to bacteria. By this experiment, it became established that DNA is a genetic material. In some viruses, RNA was also reported as genetic material, for example, TMV and QB bacteriophage. A molecule that can act as a genetic material must fulfill the following criteria. It should be able to generate its replica, that is replication. It should be stable chemically and structurally. It should provide the scope for slow changes, that is mutation, that are required for evolution. It should be able to express itself in the form of Mendelian characters. According to the above mentioned rules, both the nucleic acids, DNA and RNA, have the ability to direct duplications. Stability can be explained in DNA as the two strands being complementary if separated by heating come together in appropriate conditions. The OH group present in every nucleotide in RNA is a reactive group and makes RNA easily degradable, hence it is reactive. DNA is chemically less reactive and structurally more stable when compared to RNA. Thymine also confirms additional stability to DNA. So, among the two nucleic acids, the DNA is a predominant genetic material. Both RNA and DNA are able to mutate. Viruses having RNA genome and having shorter lifespan mutate and evolve faster. DNA is dependent on RNA for protein synthesis, while RNA can directly code for it. The protein synthesizing machinery has evolved around RNA. This concluded that the DNA, being more stable, is suitable for storage of genetic information, while for the transmission of genetic information, RNA is suitable.
About DNA and the properties of genetic material. Tomorrow we will talk about the RNA world.